Good morning po, ma'am. Yes po, rinig po.
Okay, thank you, thank you. Okay, so for today, magi-discuss lang tayo ng intro about turbines. Then, tapusin natin pala hanggang formulas. Then, for next week, doon tayo magka-problem solving. Since meron na pinapol sa inyo si Jewel, Ma'am Jewel nyo, ata. So, ang nanalo daw sa poll is online classes this week, then no classes next week, then face-to-face ata yung no classes. The next week is online na naman. So, yun. Tutuloy natin yung discussion natin ng problem solving ng turbines and plus yung discussion natin about velocity triangles sa next week. So, meaning, dire-diretso yung vacation nyo until November 4 and 5. Okay? So, yun. Dito, mabilis lang din tayo since yung iba daw is hindi pa nakakauwi ng kanilang mga bahay-bahay. So, meaning nasa boarding house pa sila. Then, bibilisan lang natin yung ating discussion for today. Okay? So, start na tayo. So, madali lang yung midterms, no? Basta nag-aral and yung formulas, istandaan nyo. And yung conversion lalo. So, parang ganon din dito, parang ganon din yung turbines. So, same as pumps. Kasi, pag may draft tube, pwede siyang maging pumps, yung ating turbine. Okay, so a turbine converts the energy of a fluid such as steam, gas, or water into mechanical energy. So, this generates mechanical energy which can be used to drive tools or machines or to generate electricity through a generator. Turbine is a rotating part that converts kinetic energy into mechanical energy or into electrical energy. So, ang intended application ng turbine or the intended application determines the design and the size of the turbines, which come in a variety of sizes and design. For example, gas turbines are commonly found in water. Tama ba? Gas turbines are commonly found in power generation in aircraft engines. So while steam turbines are more often used in power plants to generate electricity. So for hydraulic turbines or water turbines, it produces electricity from the flow of water and are used in hydroelectric power plants. So for terms and definition, so reservoir, a large area in which a huge amount of water is being stored here. So the energy here is in the form of potential energy. So yan. So yung fluid natin is coming from the reservoir. So ang working principle ng ating turbine is when any fluid strikes the blades of the turbine, the blades are displaced which produces the rotational energy. So when the turbine shaft is directly coupled with generator, mechanical energy is converted into electrical energy. Okay, so spillway are used when a reservoir is full to pass flood water safely or to discharges excess water in a controlled way. Dam, the concrete structure that encloses the reservoir. Penstock, or it is called as pipe. So the water stored at the dam or head pond is being released by the control gate. So the water starts moving to the turbine through it. Control gate, it is used to regulate the flow of water. So when the control gate is fully opened, the speed of the water flowing is at maximum. Okay? So next, terms and definitions. So valve and nozzle. So the valve works similar to the control gate, while nozzle is used to strike water in a specific direction that is a turbine blade. So surge tank, it is used to reduce pressure forces during the acceleration of the large water masses. It is used to observe the excess pressure rise in case of sudden valve closure. So tail race, channel that carries water away from the hydroelectric plant. Tail water, it is the water or the discharge water to the turbines. Draft tube, it reduces the velocity of the discharge water to minimize the loss of kinetic energy at the outlet. So dito si draft tube, ang meron lang draft tube is si reaction turbine or yung meron tayong medium and low head plants. So mamaya makikita nyo meron tayong low head plants, medium head, and high head. So para siyang compute mo yung total dynamic head, then dun mo made-determine if low head ba siya, medium head ba siya, and uh, high head ba siya. If meron tayong draft tube, meaning siya ay medium and low head plant. Okay? So yan, pwede siyang maging pumps. So pwede siyang maging, yung turbine natin, pwede maging pump dun sa medium and low head plants natin. Guide or stay vane used to convert a part of pressure energy of the fluid at its entrance to the kinetic energy and then to direct the fluid on the runner blade at the angle appropriate to the design. So there are two classification of turbines. So una is si reaction turbine and si impulse turbine. So under the reaction turbine, meron tayong Francis, Kaplan, and propeller turbine. Then under ni impulse turbine, meron tayong Pelton turbine. Pag sinabing reaction turbine, meron siyang reaction forces. So si reaction force is a force that acts in the opposite direction to an action force. So meaning, as the water crosses the curved blades of the runner, the water is deflected sideways slightly. So this causes the water to lose some of its whirl motion. So the process of water being deflected through the runner blades results in a force that pushes the blades in the opposite direction as the water is deflected. So itong reaction forces na to is like Newton's third law of motion. So it is what causes power to be transferred from the water to the turbine shaft maintaining rotation. So pag sinabi namang impulse or under nito is si Pelton turbine, so impulse is a certain amount of force you applied for a certain amount of time. So this simply means that instead of moving as a result of a reaction force, water creates some impulse on the turbine to get it to move. So dito, under nito, makikita nyo meron tayong mga YouTube links. So para mas maintindihan nyo yung working principle ni turbine. So dito, dahil nga wala naman tayong class sa November 4 and 5, so pwede kayong, yun na lang yung assignment sa inyo na panoorin nyo na lang yung mga links na nakalagay dito. So ipapasa ko naman yung PowerPoint, isasend ko to sa inyo. So after na lang ng class ko hanggang 5. So siguro, basta within this day, isasend ko na to sa inyo. Okay? So next, classification of turbines para sa para mas madali nyong ma-distinguish ano ba ang differences ng tatlo. So si Pelton, si Francis, pag sinabing Francis, it is mix ng reaction and impulse turbine, and si Kaplan yung reaction turbine natin. So, nandito na yung mga type, direction of flow, head, flow rate, type of energy, pressure of water, power generation, and lalo na yung ating efficiencies. So, yan. So, yung head natin, pag sinabing Pelton turbine, high head talaga siya, pero kabaliktaran yung flow rate natin pag Pelton. Siya ay meron siyang flow rate or yung discharge flow rate na low lang siya. Pero pag si Francis, parehas siyang medium. So, Francis M, medium-medium yung head and yung kanyang discharge. While si Kaplan, meron siyang low head, pero mataas naman yung kanyang volumetric flow rate. Okay, so ang pinakamataas na efficiency dito is si Kaplan talaga. So, the Kaplan turbine gives higher efficiency about 90%, 90%. While ang pinakamababa naman is si Pelton turbine. Okay, so for classification of turbines, so makikita nyo dito sa graph. So, sa y-axis, siya ay head in meters and sa x-axis is yung ating flow rate. So, yun yung diniscuss ko kanina na yung nasa color blue, Pelton siya. And yung nasa color red, si Francis, sorry, si Francis. And yung nasa yellow is si Kaplan. So, makikita nyo pag high head siya, pero yung kanyang flow rate is low. So, si Pelton siya. Pag medium head and medium flow rate, si Francis. And yung ating low head and high flow rate siya ay si Kaplan. So, ang uses of turbines, so turbines, yun nga, pwede siyang geothermal power plant where steam from underground reservoir is used to drive turbines and generate electricity. So, pwede din siyang iba't iba. Pwedeng gas turbine, maging steam turbine siya. So, depende sa fluid natin gagamitin. Pag si gas turbine, so yun yung ginagamit sa mga naval ships to generate electricity and provide propulsion. And pwede din siyang it can be utilized as internal combustion engines. So, yun, may mahahaluan to ng combustion. So, parang di ko alam kung na-discuss na din sa inyo 'to ni Ma'am Jewel niya. Okay. So, next puwede ding steam turbines. So, are used in various medium to large scale industries, including chemical plants, waste treatment facilities, oil and gas, and sugar mills. Puwede din siyang yung mga wind turbines, dun sa sa Ilocos. So it can produce 100 kilowatts to megawatts of power and contribute to the grid. And pwede din siya sa hydro, electric power plants use water turbines naman with high head plants utilizing impulse turbines for power generations. So yan. So madaming pwedeng gamitan ang turbine. So pwede din siyang pumps pag meron siyang draft tube. So, important formula. So, ito ay naka-highlight naman dito. It is for impulse or Pelton turbine. So, makikita nyo dito sa graph is doon sa pinakababa na the turbine cannot be used as pump since there is no draft tube. Pag sinabing impulse or Pelton turbine, so wala tayong draft tube. Okay? Kasi si draft tube, ang pwede lang is pag medium and low head plants lang siya. So, si impulse kasi, it works on the principle of Newton's second law. So, it has a number of elliptical half-sized buckets fitted inside the blades on the rotor. So, when the water strikes the bucket at high speed, the rotor starts rotating, then the kinetic energy of water is converted into mechanical energy. So, parang ganito din yan sa pump, di ba? Parang ano siya, ah, wala lang siyang draft tube. So, siya ay potential energy plus kinetic energy lang siya minus yung ating frictional head loss. So, ito is example lang 'to na parang, ah, conclude the velocity or the velocity at entrance or velocity at point A is equal to 0, kaya nagkagano'n yung ating and wala din siyang static head. So, for ano lang 'to, sample only. So, sa mismong problem is meron siyang 'pag may binigay na entrance velocity, static head, so gagamitin natin siya. Okay. So, then friction head loss. So, dalawa, puwede siyang Darcy and Morse. So, pero 'di ba si Darcy is equal to 4 times Morse. So, hindi natin gagamitin si Morse since yung value niya lalayo sa sagot mismo natin. So, mas accurate si Darcy kaysa sa Morse. Kaya lagi natin ginagamit si Darcy. Okay, so ganun lang siya. Net head is equal to gross head minus the friction head loss. Or yun yung ating TDH na. Then ito naman is for reaction turbines. So gano'n din. So meron lang 'tong draft tube since the draft tube is part of the turbine, the net head across the turbine for the conversion of mechanical work is the difference of total head at inlet of the turbine and the total head at the discharge from the draft tube at the tail race. So gano'n din naman siya. So reaction turbine in this turbine blades naman, it is designed in such a way that force is generated on the side when water flows through it like an airfoil. So the force produces by the water is responsible for the leaf and makes the blade rotate. Okay, then yan. Another important formula is for velocity of water jet at the inlet. So pag merong given tayong CV, which is the coefficient of velocity. So coefficient of velocity is ranging from 0.98 to 0.99. So kung wala namang given, okay lang, the square root of 2gh or the gravitational acceleration times the uh, TDH or the total dynamic head. Hence, the coefficient C is equal to net head on the turbine over the gross head. Fluid or water power, so para tong sa pumps, YQTDH, it is the specific weight of the water times the volumetric flow rate times the net head on the turbine. Peripheral coefficient or the speed ratio, it is the ratio of the peripheral velocity to the jet velocity. So pag tinanong what is the velocity of the runner lang, so ang gagamitin nyo lang is pi dn. Okay? Pag sinabi, what is the velocity of the jet? Square root of 2gh. So, gagamitin nyo po. So, pag sinabing peripheral coefficient, so, velocity of the runner over the velocity of the jet or the jet. Okay, then generator speed. So, it is equal to 120 frequency must be in hertz, so ating frequency, over the number of poles. So yan, important formulas, another important formulas for turbines. Pag turbine efficiency is equal to brake power over the fluid power. So turbine output can be computed as specific weight times the volumetric flow rate times the net head or the total dynamic head times the turbine efficiency. Generator efficiency is equal to generator output over the brake power. So generator output is equal to specific weight times the volumetric flow rate times the net head or the TDH times the turbine efficiency times the generator efficiency. Next one is the specific speed. So dito, magkaiba yung ating formulas na gagamitin for the SI in English unit. So, significance, the specific speed is that the specific speed of a turbine is the speed in RPM at which a similar model of the turbine would run under a head of 1 feet when of such size as to develop 1 horsepower. So, ang initial turbine selection is usually based on the ratio of design variables known as the specific speed. So, pag na-compute mo ang specific speed, so specific speed will predict the information about the performance of a turbine. So, for example, nakakuha ka ng specific speed na 17. So, meaning ang type of turbine niya is Pelton wheel with one nozzle. Okay, so yan, nakalagay naman sa table. Pag 1630 Pelton wheel with one nozzle, 30 to 70 Pelton wheel with two or more nozzle, 70 to 400 Francis turbines. So under ni Francis turbines, determine nyo pa yon kung ano siyang type ng runner. If slow ba siya, normal, high speed, or special high speed. Pag naman 400 to 800 propeller turbine with non-adjustable vanes, 800 to 1,000 Kaplan turbines. So ito yung selection of turbines. Table siya. So mas maganda pag face-to-face to para mas maintindihan nyo. Pero madali lang naman siyang intindihin. So ito, pag na-compute nyo yung power or yung ating head, So, made-determine niyo din yung kanyang specific speed or kung ano man para less ano na din, less computation sa inyo. Pero yun nga lang, maghahanap din kayo dito, parang iko-connect-connect nyo yan. So, for example, given ang head, tapos ang power, so made-determine mo kung anong klaseng turbine siya, then ano din yung specific speed niya. So, ganito lang, mas maganda na sa face-to-face. So, i-discuss natin 'to 'pag face-to-face na lang. Okay. Yeah, yes. Okay, problem solving na tayo next. So, yun lang. So, yun lang yung about turbines. Okay, any questions or clarifications po?
Wala naman po, ma'am.
Okay, so same lang siya ng, pumps. Madali lang din siya. Actually, madali lang talaga ang fluid Mach basta nag-aral in formulas plus conversion. So, pare-parehas lang kasi yung kanyang fluid power, water power, TDH, gano'n lang. So, analyzation lang din. So, yun. So, feeling ko nasa vacation mode na yung iba, yung mga utak natin na gusto ng magbakasyon at wala na ma-absorb. So, feel ko hanggang do'n lang yung aking i-di-discuss. Then, yun nga, next week, problem solving tayo. Then, velocity triangles, yon medyo maano yung velocity, medyo mahirap intindihin, pero try natin ah, mas mapadali kung paano kayo discuss yung velocity triangles. Kasi medyo nakakalito yon dahil ilan bang velocity triangles. Magkakaiba yon kasi depende sa tama ng bucket. 'Pag halimbawa, Pelton ang ginamit mo, magkaiba sila ni, Francis and ni Kaplan. So, try natin siyang padaliin. Okay, so kung wala ng questions, clarification, since meron pa mga nasa boarding house ata, eh, hindi pa nauwi sa kanila, so 'yan, idi-dismiss ko kayo ng maaga, okay? So, thank you, engineer.